Hi everyone, this is a video for examples 2 and 3 from the trig notes. I had missed those out of my last lesson video, so I'm going to talk you through these just now. It is basically using the formula that we used for area of a triangle as a half AB sine C, but applying it to different situations. So in this case we're trying to find the angle, and in the next case we'll be trying to use this formula in a non-calculator question. Now for this particular triangle, I am told that the area is 40 centimetres squared, and I want to calculate the angle at ABC. Now the angle ABC is in there at the top of the triangle, which is good because it is enclosed by the two sides that I am given the numbers for, which means I can use the formula a half AB sine C. Another thing to be aware of is that we're trying to find the obtuse angle. Now that will come in slightly later on, but right now we'll start with the substitution and rearranging. Okay, so I know the area is 40, so I'll write that in place of the A. A half, small a, will be 15. Small a and B are the two sides of the triangle, with C, capital C, being the angle. Now I'm going to replace C with capital B, since it's the angle at B that I'm trying to find. So when we first of all do the calculations on this set of numbers here, so a half times 15 times 200, pop that in the calculator, we will get 150 times by sine B, and if we rearrange that, then we will get 40 over 150 equals sine B. I'm going to flip the sides here just so I have the thing I'm trying to find on the left hand side. Now the next step here is, if we remember back to when we were looking at solving trig equations, if we've got to use sine, so sine of B, B is the angle. If we want to find that angle, generally it was x when we were looking at trig equations, we will use sine minus 1 of 40 divided by 150. Okay, so we'll pop that in the calculator, shift sine, 40 divided by 150, and we'll get an answer of 15.5. Now 15.5 is supposed to be our angle here, however B cannot possibly be 15.5 because we're talking about an obtuse angle, which 15.5 is not. If we remember back to doing trig equations then, we would, once we had worked out what we had to divide by, so what we had to put inside the brackets here, we would use our cast diagram. So all sine, tan, cos. We had x in here, 180 minus, 180 plus, and 360 minus. We're taking in something from a different topic here to try and find out this answer. Now, since we are working with sine and we're positive, we would be in quadrants A and S. That tells me that x, the value, of the angle, is either 15.5 or it's 180 subtract 15.5. So let's see what happens when we do that calculation. Now, if we do this calculation, we will see that we get an obtuse angle of 164.5 degrees. And that there will be our angle instead of the 15.5. Remember, there's always two possible answers to this. It will be instead 164.5. So our final answer here is 164.5 degrees. Okay. That you won't always have to do this. You won't always have to find the obtuse angle, but just make sure that you're relating it back to the question. So you get an angle out, it doesn't really make sense, relate it back to the question, then think about what else you have done additionally with finding angles from sine, cosine and tan. Okay, so down to another application of this area formula. We have got in this case a triangle, and we are told that sine 30 is equal to 0.5. Now, the reason that we're told that is so that we can use this in a non-calculator example. So calculators away for this one. We're still using area equals a half AB sine C, since it's a triangle and we're trying to find its area. So a half, now A and B are our two sides that we know, so times 6 times 8 times sine, C is always the angle that's enclosed between those two sides, so it has to be sine 30. Now, what we can do here is say that, right, so it's a half times 6 times 8 times sine 30 we were already told is 0.5. So we can replace that sine 30, that term, by 0.5. Now, half of 6 is 3. We want to times that by 8, times that by 0.5. 3 times 8 is 24. That needs to get times by 0.5. Now the additional trick here is to remember or recall that 0.5 is the same as a half. So timesing something by 0.5 is the same as halving it. 24 half then is 12, and our units will be meters squared. Okay, now as before with like the volume questions and stuff like that, and the arcs and sector questions, if you are given this in a non-calculator paper, you'll be given numbers that work out. Okay, you'll be given sine of your angle that you have to use, and you'll be given easy numbers that you can divide as well. Okay, so that's all for this video. Can you go please to the Teams page and you'll see some questions to do based on these questions as well. Okay, good luck.